All right, guys, good morning. We're going to talk about another one of our transformations here. We're going to go through dilations. And again, as with all of this stuff, the mathematics is pretty easy. 90% of the issue is just plotting points. This is an asynchronous homework, so hopefully you're going to follow about this if you're doing it in 2026. A dilation is basically like when you take something and you expand it or you shrink it. So we're going to go with expanding or shrinking. Sorry for my horrible handwriting. This is the very first thing I've written all morning. Of a figure based to a fixed point called the point of dilation. For the most part, who really cares? Okay, not that important. A dilation is an example of non-rigid because we are going to be changing our shape a little bit, and a dilation produces how about an image, I guess, just as before. We've got the original and we've got the image. All corresponding angles are congruent. I see. It produces a similar shape. Not a congruent shape, but a similar shape. Again, it's not that important. Scale factor. A scale factor is sometimes written as the variable k. When k is greater than 1, the dilation is a expanding. When k is less than 1, the dilation is a shrinking. Now, this might sound really complicated. We're basically just talking about you're going to get a number for how much it should shrink or how much it should expand. Okay, so if we look down here and it says k equals 2, okay, the idea here is that we want to make this 2 times as big. And when it says k, that just means how much that we want to make it bigger. So if we plot these points of -5, 1, -5, 1, -3, 4, 2, -1. Now this is a medium-sized triangle, and we want to make this triangle twice as big. Now the good news is this is very easy. All we have to do is make all the numbers twice as big. Times 2, times 2, -5, 1, it needs to become -10, 2. Just literally make it twice as big. -3, 4, that's the S, -6, 8. The T is 2, 1, so we need to make it 4, -2. Just make it twice as big. Now, when we do this, we don't need to worry about any sign changes. All we need to do is make it twice as big. Now let me get some colors out here. All right, our new points of -10, 2, -10, 2, -6, 8, -6, 8, and 4, -2. Now we draw this shape. And we're going to end up with 2 similar shapes, but one of them is going to be bigger or smaller than the other. And this is a dilation. This is all you have to do is just make it bigger or perhaps smaller. We'll see a smaller question in a little bit. This is as easy as it looks. Okay, you have this yellow triangle here. This is the image, and then you have this pink triangle here. This is the pre-image, and that's the whole thing, okay? More or less, our job for today is to plot points and to look at this value here, this k, which is our scale factor, which tells us how much we want to scale it bigger, and just to scale it up. So now we have a k of 3. That means we want to make it 3 times as big. Negative 3, 0, 1, 2, 2, 0, and negative 2, negative 2. 3 times as big, I'm going to take all these numbers. Negative 3 times 3 is 9. 0 times 3 is 0. 1, 2 is going to be 3, 6. 2, 0 is going to be 6, 0. And negative 2 is going to be negative 6, negative 6. Again, the negatives and the positives will never change. It's just the numbers are getting 3 times as big. Negative 9, 0. 6, 0. 3, 6. I did this in a very weird order. Negative 6, negative 6. And there you go. Now hopefully you're starting to recognize that we kind of have the one shape that is kind of growing a little bit on the outside of our shape. I guess the last thing that we can talk about is if your shape is around the origin, because the origin is how we're going to be growing, then your shape will become inside of the other shape, right? That because we're spreading out on the origin, it's going to grow up on the inside. Now, if we look at this example question here, the original was not around the origin, and that means that once it got dilated, once it got expanded, it didn't end up around the shape. So not every single answer is going to have your shape on the inside. What matters is if your shape is kind of inside the origin, then you're going to end up with it on the inside. So I'm going to speed it up a little bit here. You can see now we have 3 halves. Okay, now 3 halves, this is a little bit of an annoying question. Honestly, we're just not going to do this one. That's kind of like a straight geometry kind of question. Looking at this one, 3/4 is more interesting. Okay, now very importantly, 3/4 is less than 1. Okay, so this is a situation where we have k is less than 1. That means we're going to need a shrink. Now let's also just use common sense. Look at this big shape. Do we have any room to make this big shape even bigger? Definitely not, right? We have no room to make this shape even bigger. Of course, we're going to end up shrinking it. Now, in order to do that, all we need to do is multiply by 3/4. Our brain, we're going to kind of struggle to do that in our head a little bit. To be honest, a lot of the time that we do these questions, whether we take a quiz, whether we take a test, a lot of times it's just going to be 1/2. Okay, our brain's pretty good at just multiplying by 1/2, cutting shapes in half. 3/4, this is about as hard as it gets, to be honest. All I need to do is take my coordinates and multiply by 3/4. Well, I don't see the coordinates, so I need to find them myself. A here is at 1, 2, 3, 4. A is at -4. 1, 2, 3, 4, 5, 6, 7, 8. -4, 8. And I need to multiply these times times 3/4. So here's a calculator, and the first number was -4 times 3/4. -3. negative 3. The next number was negative 8 times 3/4, negative 6. And so, negative 3, ooh, hold up, Mr. Collier. Positive 6 should be right here. Now again, this is something that it's not rocket science, guys. We're just trying to shrink the shape a little bit. 3/4, if you didn't know, 3/4 is like 75%. And so we're hoping that this shape is going to be about 75%. And it looks pretty good. Okay, let's go to this next shape, this next point B here. 1, 2, 3, 4. This is 4. And 1, 2, 3, 4, 5, 6. This is 6. Okay, what is my B prime going to be? 4 times 3 divided by 4 is 3. And 6 times 3 divided by 4. Oh, okay, I got 4.5. Now, again, I don't really see a lot of this, to be honest, but if we do, guys, we can still figure it out. Let's go to 3. 1, 2, 3, and let's go to 4.5. 1, 2, 3, 4.5. Again, I wouldn't stress too much about this half thing. It is what it is. And the last one here is 1, 2, 3, 4. So this point is at 0 in the x direction and negative 4 in the y direction. 0 times 3 divided by 4, obviously it's going to be 0. And 4 times 3 divided by 4 is going to be 3. Okay, 0, 3. Ooh, negative 3. I've been a little bit lazy with my negatives this morning, guys, so definitely make sure you're careful with that. And there's my shape. Now again, all I'm trying to do is either shrink or grow the big shape that I start off with. And so this does look pretty good. Okay, it is shrunken down, and the scale factor is how much I want to do it, whether I'm getting bigger or smaller. Matters if this number is bigger than 1 or less than 1. Now here we have a couple of questions, and the idea is these are easy. Okay, we definitely want to feel comfortable with these. It says that A prime is the image of A after a dilation centered on the origin. Okay, it doesn't really, that stuff really matters. With a scale factor of 2. So if A prime is the image after a dilation, and that means we want to go backwards. Okay, instead of doing another times 2, if we already did the dilation, then we want to undo the dilation. And so we want to take these numbers and we want to undo a times 2. Now, if you want to undo a times 2, that means we're going to need to divide by 2. Now, I got to be honest, guys. This is a pretty simple concept, okay? You have a point, and after you dilated it, it's negative 10, negative 8. You got to be able to follow the process of saying, I'm not trying to dilate it again. I'm trying to undo the dilation. Now, you'll notice that that is a pretty similar pattern here because it says after, after, after. So a lot of times, these questions, they're not going to ask you to do the dilation because all you would have to do is multiply, and that's kind of like a question for like a 5th grader. Instead, they're going to say, here's the point after a dilation, and so your job is to kind of undo it. Okay? So let's see how this is going to work here. We're going to be dividing by 2, and this is easy. Negative 10, negative 8. We're going to want to divide by 2 and divide by 2. So our final answer is going to be negative 5, negative 4. P prime is the image of P after dilation. After a dilation is centered about the origin with a scale factor of 1/3. So the idea here is, again, we don't want to be multiplying times 1/3. Instead, we want to be undoing it. So we want to be dividing by 1/3. Now, if we want to write this down, we want to undo a times 1/3. That means that we want to do a divide by 1/3. Now, honestly, dividing by fractions is something that nobody likes to do. Dividing by fractions is a little bit ugly. I remember that you learned this in Algebra 1. You learned the keep, change, flip method. And if we want to divide by 1/3, we have to be a little bit careful of how we type it in. If I type -2 divided by 1/3, I get this number. If I type -2 divided by, and I'm going to have to upgrade to parentheses 1/3, we get this number. So we're getting two different answers here. -2 divided by 1/3, that's a decimal, or -2 divided by parentheses 1/3, we get this number. Now hopefully you feel pretty good that the -6 is the right answer. Our job here is that we're trying to do the opposite. So it looks like what we did with the scale factor of 1/3 is that we shrunk. And so we want to unshrink. We want to get bigger. If the scale factor is 1/3 and you're trying to undo it, okay? This divided by 1/3, we can write it as a times 3. Right? Because what we did before is we made it 1/3 as big, we shrunk it down. So this time we want to make it 3 times as big and do a times 3. We're going to end up with -2/5 times 3 times 3. We're going to end up with -6/15. We've got a z prime here, and again, this is our 3/2 question. I'm not really worried about the 3/2 question at this level. And so let's go faster here, right? It says that the scale factor is 1/2. Okay, 1/2 doesn't bother me at all. I want to undo a 1/2. That means instead of divide by 1/2, which is dividing by a fraction, maybe it's better if I say that we want to do a times 2. I've got 1.5 and -4 times 2 times 2. I've got 3 -8. The last two questions here are about identifying a scale factor. That means that we're looking at the two pictures and we need to figure out how much did it grow or how much did it shrink. Now the first thing with these questions that we need to make sure that we do is find the original. All right? It's not super clear which one of these is the original shape, and the way we do it is we look at the letters. Okay? This one is a D, an E, and an F. This one is a D prime, an E prime, and an F prime. So that means that the original is the big one for this question. So how much did this pink shape grow or shrink? How much did it expand or shrink? Okay, this is clearly a shrink. Now, how can you identify how this works? The strategy here is that you need to find some coordinates and compare them, okay? I'm gonna find any of these coordinates, and I wanna find a nice little pair of them. So maybe I'll look at the D coordinate here. All right, I'm gonna look at D, which is 0, 1, 2, 3, 4, 5, 6, 0, 6. I'm gonna look at D prime, which is 0, 2. And I'm gonna think, how much did it shrink in order to do this? Now I wanna be a little bit careful, okay? Because if you're not paying attention, honestly, if you're still watching, great job. There's gonna be people who kind of turn the video off, or maybe they've got me muted, or maybe they just skipped ahead and copied down the information. Very important here, okay? This is not -4. I know it's gone from a 6 to a 2, but this is not -4, okay? When it comes to dilation, everything that we do with dilation is about multiplying or dividing. And so I know that the 6 turns into a 2 with a -4, but not for dilation. Okay, so we're not going to put -4. We have to think about either multiplying or dividing. So how did the 6 turn into a 2 if it used multiplication or dividing? The easiest way to think about it is to say divided by 3. That's how you can turn a 6 into a 2, is you can divide it by 3. Well, when we write our answer, we like our answer to always be in the multiplication form, not in the dividing form. So instead, we're going to say times 1/3. And this is our scale factor of 1/3. Now, if you're not sure how to do this, and your brain isn't doing it for you, and you want to incorporate the calculator, what you do is you take the image of 2 and you divide it by the pre-image. Now that 0.333333, obviously that's going to be 1/3. And so if you're on a Desmos, you can make an easy fraction like that. Okay. Let's do one more question, and we'll go quickly on this one. Let's find any points that we want. It doesn't matter. Maybe I'll choose this W here. I do want to make sure I find the original. This is the original. That means that this is a clear expanding question. So this is an expanding question. Oh, the lights are turning off on me. Just been sitting at my desk for too long. This is a clear expanding question, and so the W here has a value of -2, -2. The W prime has a value of -8, -8. That means I need to think about how much did I expand when I went from a -2 to a -8, and I have to think about multiplying, not adding, not subtracting. How do I think about multiplying? And so you turn a -2 into a -8, multiplying by 4. So the answer is going to be times 4. Okay, we've done pretty much every question on this worksheet. The main idea here is that, well, unless I have the notes right here. Dilation is all about multiplying, okay? And you're going to be multiplying by a scale factor, which that's just a vocab word. Don't be intimidated by that. For the most part, most of the questions are going to be twice as big, 3 times as big. Maybe we'll see a question that has to do with shrinking, where this number is less, okay? You can be a little bit careful here, but just multiply by 3 over 4. We did some questions in the middle here where we had the image and we were trying to find the pre-image. We were trying to go backwards. Whenever you're trying to go backwards, we want to kind of keep a little bit of like a math strategy in our head. That dividing by 2 is the same as multiplying by 1/2. So when we see something like scale factor of 2 and we want to go backwards, which means we want to divide by 2, that would be the same thing as multiplying by 1/2. So we're going to have to incorporate fractions a little bit and multiplying fractions, and if we do it, if we take our time, it's not too bad. But if we kind of half pay attention, then these questions are missed by a lot of students. Find the original here. I look at 0.6 and I see 0.2. I need to do a shrink and I need to divide by 3. But we like it to be written as the multiply number, which is a times 1 with the 3 on the bottom. All right, this is a piece of paper. Obviously, we'll talk more about this when I see you guys tomorrow. Hopefully you've got this all written down so that you can get a nice 100% homework grade. And hope you enjoyed your little semi-day off. Have a great day, guys.